All right, so here's the homework for the intercept form. So first off here it says match the equation with its graph. So how am I going to do this? Well, first I'm going to look at the forms. X minus 1 squared, there's no constant here, so this is vertex form. This one right here is intercept because I see two x's, so x plus x minus p, x minus q, so this is intercept form. And the reason I'm identifying this is because it's going to help me to decide how to find my answers quickest. This is also intercept form because of the two x's. And this we can see h, k, so a, h, and k, this is going to be your vertex form. So here with this vertex form, I know that the vertex should be at 1, 0, right? The h is opposite 1, there is no k value, so 0. And it's also facing up. So I'm looking for a vertex of 1, 0 facing up. So A is a possible choice. These three are facing down. And these are not have the they don't have the vertex at 1, 0, so this is the answer choice of A. For number 2, I said it's intercept form, and there's no A value, so the A value is positive 1, so it's facing up. So my answer choices are really just between C and F. So remember, for my x-intercepts, it's going to be the opposite. It's like setting it equal to 0 and solving. So the opposite of this is 2, 0. So the opposite of x plus 4 would be negative 4, 0. So I see 2, 0, negative 4, and this one you can see doesn't even cross. So this would be my answer. For number 3, once again, it's intercept form, and it's facing down. So I have choices B, D, and E to look at. So here now I'm not going to write down my intercepts, but opposite of this would be 3. So 3, 0. This has 1. This has 3. This does not have 3, this does not have 3, so my answer choice is going to be E. And then last, this one is facing up, and I mean, the only one facing up is this here, but if you look at the vertex, opposite of that is 2, positive 1, so if you were to go right 2, up 1, you would see it hits the vertex right there, and the answer is F. All right, for numbers 5, 6, and 7, it says write the quadratic function in standard form. So when it's just intercept form, you FOIL it out and you distribute the constant in the, or coefficient in front, and you add or subtract the constant at the end if they're there. In this case, they're not. So here we have x times x, which is x squared, x times negative 1, negative x, negative 3 times x. We're distributing that negative 3 now. And negative 3 times negative 1 is positive 3. I'm not sure why I wrote that extra parentheses there, not necessary. And y equals, we combine our like terms, so this is x squared. Negative x minus 3x is negative 4x, and then positive 3. Okay, for the next one, it's intercept form again. It appears all these are intercept form. So we're going to leave the 2 alone, and we're going to FOIL this out. So x times x is x squared, so we're distributing the x. X times 4 is 4x. Now we're going to distribute the second term, which is 1. 1 times x is x. 1 times 4 is 4. Now we're going to combine our like terms. X squared, this is going to be 5x, positive 4. And last, we're going to distribute this 2 across the whole thing. So 2x squared plus 10x plus 8. And then for my last problem here, same thing. We're going to first start by FOILing out the x here. So x times x is x squared. X times 3 is 3x. Negative 2 times x is negative 2x. Negative 2 times 3 is negative 6. Now we're going to combine our like terms. So x squared, 3x minus 2x is positive x, minus 6. Last, we distribute our negative 3, and we come up with our standard form. So negative 3x squared, negative 3 times x is negative 3x, and negative 3 times negative 6 is positive 18. All right, now we're on to the next problem. So for this one here, it says find the minimum value or the maximum value of the function. So I'm going to do this one by hand. So the way I do this one by hand is, first, I know the minimum value is the y value of the vertex, whether it be minimum or maximum. So I'm looking for the y value of the vertex. All right, so here, let's start by finding the x-intercepts. So in this case, opposite of that, negative 3, 0. Opposite of that, negative 1, 0. So if you recall, to find the axis of symmetry, x equals p plus q divided by 2. So negative 4 divided by 2 is negative 2. So x equals negative 2. And last, for my vertex, we know the x value is negative 2. And we're just going to plug it into this function here. So we get y equals negative 2 plus 3 times negative 2 plus 1. So y equals 1 times negative 1, so y is equal to negative 1. And there is my vertex, but the question says find the minimum or the maximum value. In this case, since a is positive, it's facing up, so we have a max value, and that would be y is equal to negative 1. All right, for the next problem, we'll go ahead and do the same steps here. First, we will find the x-intercepts. So the opposite of x minus 1, or if you set it equal to 0 and solve, would be 1, 0. And this would be 5, 0. So just to show you what I'm doing in my head, and x equals 5. All right, for the axis of symmetry, p plus q divided by 2. So it's pretty much taking the roots, adding them together, and dividing by 2. So 1 plus 5 is 6. 6 divided by 2 is 3. We now know that the x value here of the vertex is the axis of symmetry. And last but not least, to find the corresponding y value, we plug it in. So y equals negative 2, 3 minus 1, and 3 minus 5. So y equals negative 2. 3 minus 1 is 2. 3 minus 5 is negative 2. And then negative 2 times 2 is negative 4, times negative 2 is positive 8. So now, this is facing down. Ooh, I made a mistake here. This is not a max value. This is a minimum value. Since my graph is facing up, it is the lowest point. Sorry about that. This one here, my graph is facing down, so that's going to be the highest point. So that's a max value. And the max value is y equals 8. All right, moving on to numbers 10 and 11. So here it says graph the function, label the vertex, axis of symmetry, and the x-intercepts. So once again, x-intercepts, opposite of that, negative 1, 0. Opposite of that, 2, 0. To find the axis of symmetry, we do p plus q divided by 2. So x is equal to 1/2. My vertex is at 1/2, comma, and here we're just going to plug it in real quick. So I'm going to use a calculator to kind of speed up the process. So we have 2 parentheses, we change x to 0.5. And so 0.5 plus 1, 0.5 minus 2, and we get negative 4.5. For the domain, we know it's going to be all real numbers, so negative infinity to infinity. Our graph is facing up, so we have negative 4.5, comma, infinity. All right, and for this one here, we can do 1/2 and 1, 2, 3, 4.5. And I can still actually apply the 1, 3, 5, 7 rule. The a value you can see is 2. So we multiply each one of these by 2. So 1 times 2 is 2. 3 times 2 is 6. 5 times 2 is 10. 7 times 2 is 14. But honestly, when you have the roots here, it does make it a little bit easier just to graph it off those 3 points. But right here, I start at the vertex. I go right 1, and my first one says I go up 2. So right 1, up 2. And I could go right 1, up 1, 2, 3, 4, 5. And that's too high, so I'm going to leave it as this here with these 5 points. And this will make my graph. Okay, on to the next problem. So once again, intercepts, opposite is negative 3, 0. Opposite is 1, 0. To find the axis of symmetry, x equals negative 3 plus 1 divided by 2. So negative 2 divided by 2 is negative 1. So negative 1, comma, and I'm just going to plug this in here. I mean, just to make it a little bit quicker. So negative parentheses, negative 1 plus 3, negative 1 minus 1, and we get 4. So the domain, once again, is still going to be all real numbers. That will not change. But for my range, this time it's facing down, so that means it's coming from negative infinity, and it's reaching a maximum value of 4, and that's a bracket. All right, so when we do this here, we have a negative 1, positive 4, 1, 2, 3, 4. And then our roots are at negative 3, 0, 1, 2, 3, and 1, 0. And just based on this, like I'm going to do 1, 3, 5, 7, A value is -1, so multiply each one of these by -1. So we have -1, we have -3, we have -5, and we have -7. So write 1, down 1, write 1, down 3, write 1, down 5, and you can see that it lines up, but I can't go too far because the graph does not allow it. And there is my graph. All right, last we have this. It says, in exercises 12 and 13, use the following information. So it says the flight of a particular golf shot can be modeled by this function right here. And just looking at this, I can tell that it is in intercept form because there is an x and an x, where x is the horizontal distance in yards from the impact point and y is the height in yards. So before I even read some of these questions, I could definitely just read them and answer the questions, but I'm going to go with some of the stuff in its intercept form that I should be finding. So my intercepts, so this is just an x here, so automatically x is equal to 0. So I have a root at 0, 0. This one, x minus 260, the opposite is going to be 260, 0. If I wanted the axis of symmetry, it would be x equals 0 plus 260 divided by 2, which would equal 130. So my vertex is going to be x value of 130, comma. Now to get my y value, I take 130 and I plug it into this function here. So that's why I have a calculator available. If you want to use Desmos, you can, or the online ones. So negative 0.0013 times 130. And then we have 130 minus 260. And we get 21.97. All right, so now I have all the information that I need. So the first question asks, how many yards away from the impact point does the golf ball land? Well, so if somebody hits a golf ball and it lands over here, so our first root is at 0, 0, so we can understand hopefully that this is 0, 0. And the ball travels a path, it hits a maximum vertex at 130, 21.97. So the max height is at 21.97, and the ball lands 260, and I don't know what the units is, yards. So how many yards away from the impact point does the ball go? So it looks like it's 260 yards. What is the maximum height in yards of the golf shot? Well, we just said the maximum height is 21.97 yards.